Greatest common factor of 12 and 18. These are just two numbers, 12 and 18. What did we find out that the answer was? If you go back to the last section, you'll see that the GCF of these two numbers was equal to 6. Now, the reason why this was the answer was because this is the biggest factor, which means the biggest thing divisible into each of these numbers that are common to both. So in other words, 6 times 2 is 12, 6 times 3 is 18. All right, nothing larger than 6 works. 7, 8, 9, 10. If you just go up in the numbers, you cannot find another number larger than 6 that I would be able to multiply by something to go in. Or another way to think about it is being divisible. So keep that in mind, that that's the definition of what a greatest common factor is in terms of numbers, because the same sort of idea applies to algebra, but it's just a little difficult to think about it usually in the beginning. So we're going to do a lot of problems. So what if you had 3x squared as instead of a number? Now we have an algebraic expression, 3x squared, and 9x to the third. And we wanted to find the greatest common factor of those two things. All right, so we have to look at this guy as an entire term and this guy as an entire term. However, each one of them has a number, and each one of them has some variables. In this case, x squared and x cubed. And we're going to get to more complicated problems where we have more variables. But in the basic sense, you have number and variable and exponent. So what you're trying to do is you're trying to look at both of these guys, and you're trying to figure out what is the biggest factor, the biggest thing common to both of them. So you can kind of look at the number separate from the variable. All right. So if you just looked at the number 3 and 9, what is the greatest common factor there? I'm just going to write it down because it's just going to take some practice for you to see. Okay. The number 3 is the greatest common factor of both of those because 3 times 1 is 3, 3 times 3 is 9. Obviously, I can't use 4, 5, 6, 7, 8, and so on because none of those numbers will multiply by anything to give me 3. So 3 is the biggest number that is a factor common to both of these. Now, what would be the biggest factor common to x squared and x cubed? And that you may have difficulty coming up with until you see a bunch of these problems. I'm going to write the answer down and we'll talk about it. The answer is x squared. So the greatest factor between 3 and 9 is 3. The greatest common factor between these two guys, x squared and x cubed, is x squared. And the reason is because x squared times 1 gives you x squared, and x squared times x, think about it, x squared times x, you would just add the exponents, and that would give you x to the third. So x squared is really the biggest factor common to both of them. Look, you have an x squared here and you have something more than that over here. So you put them together, the greatest factor of the numbers and the greatest factor of the variables, and there you have it. So this is actually the answer. This is the greatest common factor of that. And I will go ahead and just kind of write it down in a little more clarity. Now to check this, to check that this is true, that that's the greatest common factor, you can think of it in a number of ways. You could say that 3x squared times 1 is equal to 3x squared. Remember, when we talked about numbers, we found the greatest common factor. 6 times 2 is 12, 6 times 3 is 18. So we need to find a number so that we can multiply by our greatest common factor, not necessarily a number, something that we can multiply by our greatest common factor to get our original thing. In this case, we can just multiply by 1. What do we need to multiply to get this as a check? Well, if we take 3x squared and multiply it by 3x, then we would multiply the numbers together, and that would give us 9. And then we would multiply the exponents together, and that would add the exponents. 2 plus 1 is 3, so it would be x cubed. So you see what we've done is we've said, hey, this is the greatest common factor. And the reason it is the exact same reason that this is the greatest common factor for these numbers. Because I can take this number, and I can multiply it by something to give me this, and I can take this and multiply it by something different to give me that. And I'm doing the same thing here. I'm taking this greatest common factor, multiplying by something gives me the first thing. I'm taking this greatest common factor, multiplying by something to give me the second thing. All right, now this is just going to have to come with practice. This is not something, I kind of expect you to sort of understand it at this point, but it's just going to take a little practice to get to the point where you understand it really well. So let's go on to the next one. Let's say you have 4 times c cubed, and then you have another term, 8 times c. So you have a number and a variable with an exponent common to both terms. So what is among the numbers, what is the greatest common factor? What's common to both of these guys? We have a 4 here and you have an 8 here. So without making a list of numbers, what is the biggest number that you can come up with such that you can multiply it by something to give you 4 and 8? And the biggest number you can come up with is 4, because 4 times 1 will give me 4, and 4 times 2 will give me 8. I can't find anything bigger than that. Now, what's the biggest variable in terms of C that's basically common to both of these, is what I'm really looking for. And the answer to that is just going to be C, because C times C squared, I would add the exponents, would give me this, and C times 1 would give me this. So you'll get the pattern as we move along here, but really all you're doing is you're looking at both of these terms and you're trying to find out what's really common to both of them. The largest thing that's common to both of those terms. We call it a factor. It's a little easier to think about factors when you have numbers, but here in these algebraic expressions, really you're looking for commonality, the largest thing that's in common. Right? 4 is in common with both of them because I can multiply 4 by something to give me this, and I can multiply 4 by something to give me 8. And then I'm looking at the C cubed and the C, and I'm really looking for commonality. I'm trying to figure out what is common between the two. I only have one C over here, and I have 3 of them over here, so I have to look at whatever the largest thing that's common to both lists. And C is the largest variable, C to the first power is the largest thing common. Now to check this, 4 times C, you could check it a bunch of different ways. Just checking the numbers, you could say 4 times, well, let's just do it this way, 4C, that's the greatest common factor, times, what would I multiply it by to give me this? I would have to multiply it by C squared, would give me 4C cubed. That's a check. And then I could take 4C, what would I have to multiply it by to give me this? Well, I have to multiply it by 2, and that would be it, because the C is already taken care of, 8C. That's a check. So you see I'm taking this greatest common factor and I'm multiplying it by something, 2 completely different things I'm multiplying by to get me these guys. You don't have to do this check every time. I'm just doing it in the beginning to give you some practice. Really, you're looking for commonality between the two terms, right? Commonality. We call that factors in math. So let's go on to the next one. You'll see the pattern a little bit more as we move along here. 15a to the 4th power, and our second term is 20, or a second monomial, 21a squared. So you're looking for commonality. What is common in terms of factors between 15 and 21? Okay, you just start going through numbers, 1, 2, 3, and so on until you can't find a larger number that works. Well, I know that 3 times 5 is 15, and I know that 3 times 7 is 21. So you can go mentally above the number 3, but you're not going to find anything bigger than that that's going to actually be able to be a factor of it. So the number part of the answer is going to be 3. Okay, that's the greatest common factor between 15 and 21, because 3 times 5 is 15, 3 times 7 is 21. Now for the variables, you just kind of look and see what's common between both of them. I have an a to the 4th power, and I have an a to the 2nd power. So what's the largest thing that's common to both? A squared is the largest thing that's common to both. All right, I couldn't pick anything larger than a squared. I couldn't pick a cubed, for instance, because if I put a cubed here, I wouldn't be able to multiply it by anything to give me this. All right, if I picked a to the 5th power here, I wouldn't be able to multiply by anything to give me that. So I'm looking for the largest thing common to both lists, and a squared is common. Now, this is the answer. This is what you would circle. This is the greatest common factor. Now ask yourself the question, what would I multiply this by to give me 15a to the 4th? I would multiply by 5a squared, right? Because 3 times 5 is 15. A squared times a squared, I would add them and give me a to the 4th, so that works out. What would I multiply this by to give me this? 3 times 7 is 21, so it would be 7, and that would be it, 7, because a squared times, there's no other a, so it would just be a squared. So you can do a little self-check to make sure you're doing the right thing. So there's not a lot of math to show for these problems. You have to look for commonality between the two. All right, but it's a crucial skill, because as we go along in algebra, you're going to be factoring expressions all the time. So you're going to have to look at two expressions and say what's common to both. And when I'm talking about what's common, I'm really talking about common factors, things that are divisible. So 10b and 25b to the 5th power. Now, just looking at the numbers, what's the greatest common factor? What's the biggest number I can pick that I can multiply by something to give me 10 and separately 25? Well, the answer to that question is 5 would be the greatest common factor of the numbers, because 5 times 2 is 10 and 5 times 5 is 25. I can't go any more than that. I can't pick 7, 8, 9, or even 10. I can't do 10 because 10 times nothing will give me 25. So this is the greatest common factor. Now among the variables, it's easier just to look for commonality and don't try to overthink it. Here I have a single b, and here I have basically 5 b's multiplied together. So I'm looking for the biggest thing that's common in terms of the exponents to both. And the biggest thing common is just a single b. And that's the final answer. Right? And you could check it. You could say, what would I multiply by to get this? I would multiply just by 2. That would give me 10b. What would I multiply this to give me this? I'd multiply by 5b to the 4th. 5 times 5 is 25. B to the 4th times this, I would add the exponents, and that would give me b to the 5th. So that is the proper factor. All right, so we're going to work a few more here at the bottom of the page. And again, you're going to get a lot more practice with this as we move on. So the next problem we have, this is a little more complicated, p squared times q to the 3rd power, that's one term, and then we have p to the 3rd times q squared. Now again, my advice, see now we don't even have any numbers. So a lot of students look at this and they're like, well, I mean we have numbers, but just in the exponents. I mean we don't have any numbers out in front like we did before. So a lot of students look at this and say, whoa, how do I do this factoring thing? All you have to do is look at the variables and find out what's common to both. You're trying to find the biggest thing that's common to both. So among the p squared here and the p cubed here, what's common to both? Well, I only have 2 p's here multiplied together and 3 p's here multiplied together. So the biggest thing common to both is just 2 of those p's. So the p part of it is just going to be p squared. Then I look at the q's. I have 3 of them here and 2 of them here multiplied together. I can't pick 3 because I only have 2 q's over there. I'm looking for the largest thing common to both. So I only have 2 q's that would be common to both of those lists. So q squared, and you multiply them together, and that's the answer, p squared q squared. So again, one more time, among the p's, only 2 of them are common, because here I have 3, and among the q's, only 2 of them are common, because I have 3 over here. Now, if you wanted to go backwards, or not backwards, if you wanted to check, let's just do it one last time. I won't check anymore, but if I wanted to say p squared q squared, what would I have to multiply to give me this first one? Well, I already have p squared, so times 1 would give me this. Q squared times q would give me p squared q to the 3rd, because I would add them together. I would add these exponents. That's what I would have to multiply to give me that. And then as another check, I would say p squared q squared. What would I have to multiply to give me this over here? Well, again, the p times something give me p cubed is going to be p, and q squared, I already have q squared, so I don't have to do anything with that. I add the p's together, and that gives me p q cubed q squared. Check. All you're looking for is that you can take your greatest common factor and multiply it by something, any variable, any number, anything at all, in order to give me what I originally started with. And those are good checks to make sure that I did it right. I'm not going to be doing these checks every time, but I did want to, help you out and give you a little bit of practice. Now our next problem is, what if we have 7 times x times y cubed, and the next one is 14 times x squared y squared. All right, so you look at the numbers. What's the greatest common factor between 7 and 14? I think you'll all agree the answer is 7. That's the biggest thing I can pick to multiply. 7 times 1 is 7, 7 times 2 is 14. Then I look at the x and the x squared. What's the biggest thing common to both? It's just a single x, because I have a single x right here and I have 2 of them right here. So the biggest thing is just x. Then I look between x cubed and x squared. What's the biggest thing common to both? Well, I have 2 of them here and 3 of them here, so y squared is the biggest common to both. This is the greatest common factor, 7x times y squared. We're just going to do 3 or 4 more of these. What if we have 4xy squared and 6x squared y? So first we look again at the numbers. We say, what is common? What is the biggest thing I can pick that I'll be able to multiply by something to give me these? And the answer is 2, because 2 times 2 is 4, 2 times 3 is 6. I can't pick anything bigger than that. Then I have a single x here, and I have 2 x's multiplied, x squared, so I have 2 of them here. What's the biggest thing common? It's just the single x. And then I look at the y. I have 2 y's here, and I have 1 y here. What's the biggest thing common to both? It's just a single y. 2 times x times y is the final answer. Now I just have, I think, 3 more of these. I'm doing a lot of these problems because this really is an important topic in algebra. I try to spend a little more time when I know it's going to be important. So 6 times s squared t squared, and 9 times s times t cubed. So first you look at the numbers. what is going to be the greatest common factor? Well, it can't be 6, for instance, because 6 times nothing works to give me 9, so it has to be smaller than that. So I start thinking about it and going through my numbers. The answer is 3, because 3 times 2 is 6, and 3 times 3 is 9. There's nothing bigger than that I can pick. Then I have 2 s's here, s squared, and I have a single one here, so the biggest thing common is just the single s. And here I have 2 t's, which t times t, 2 of them, and I have 3 of them multiplied together here, so the largest thing common to both is t squared. This is the greatest common factor of both of them. All right, next problem, we just have 2 more of these. 20ax cubed, 30a times b times x. So we're trying to find the greatest common factor. Now, at first glance, this might look weird because I have an ax cubed, and here I have an abx. So I have a b over here. I don't have any b at all over here. It doesn't matter. All you're looking for is commonality. So first, choose your number. What's the biggest thing I can pick there that I can use to multiply? And that's going to be 10, because 10 times 2 is 20, and 10 times 3 is 30. I can't pick anything larger than that. And then I look at a. I look and say, well, what is common between the both of them? I have a single a and a single a, so I have the same amount in both, so a is the largest thing common to both. And then I look at x cubed, and I look at x, so I have 3 of them here and 1 of them here. What's the biggest thing? The biggest amount of x's common to both is just a single x. And then you might look at this and say, well, I have a b here and a b here. Well, I have no b here, I mean. So I don't have any commonality. I have a single b here, but nothing over here. So there is no b in my answer. This is actually the final answer, because every single time I do this, I'm looking for commonality between both lists. But since I have a b over here and no b over here, there is no commonality in b, so you just don't write it down in your answer. The answer is 10 times a times x. Now, because this one's a little bit weird, let's do a check on this one. 10 times a times x. What would I multiply by to give me this? Well, 10 times 2 is 20, and then a times 1 is a, so I don't need any more a's. X times what gives me x cubed? It's going to be x squared. That's going to give me 20a x cubed. We just add the exponents. That's a check. Now let's check the next one. 10 times a times x times what is going to give me this? 10 times 3 is 30, and a times 1 is a, so I don't need any a's there. And then I have a b here, right? So I'm going to need a single b here, and then x times, there's only one x here, so I don't need any more x's. So look what happens if I choose 3b. 10 times 3 is 30, a times b times x. You see, just like it sits here, and that's the answer. Check. All right, so you need to be able to, when you're checking them, and you don't always have to do this, I'm just kind of showing you to show you how it's a factor. You can pick anything you want. I needed to stick a b in here because I had a b in this answer, but I didn't have any in my factor. So factors are things, it's basically common divisors, things that are divisible by both. There's no b over here, so there's no b in my greatest common factor. All right, final problem. What if we have 25 times p squared times q times r, and then we have 36 times pr cubed. So first, again, I look at the numbers, 25 and 36, and I try to think, okay, what can I do here? Now this one's a little bit weird, that's why I'm bringing it up, because you try to look for a greatest common factor here, and you really can't find one, because the factors of 25 are things like, 5 and things of that nature, but nothing I can pick that's going to multiply to give me 25 will also be able to be multiplied by something to give me 36. So really, the number 1 is really the greatest common factor. 1 times 25 is 25, 1 times 36 is 36. I can't find anything bigger than that. So I guess the answer is you're going to have a 1 down here, but you don't need to really write the number 1. So then you start looking at your variables. I have a p squared and a p. So I have 1p and 2p, so the largest the thing common to both is just the p. And then I have r here and r cubed here. Well, let me back up for a second. I have q right here, but I don't have any q's over here, so it's not common to both lists. It doesn't show up in my common factors. I have r and r cubed, so I have single r and 3 of them, so the biggest one is going to be r. So this is actually the greatest common factor, p times r. And that may look a little bit weird, especially because of the numbers and the fact that I couldn't find a common factor from those. But remember, the point of greatest common factor is to find commonality between two lists of things, right? The only thing common between these two as far as factors go is the single p, because I had a p squared and a p here, and a single r, because I had the r here and I have r cubed here. That's it. Now, if I wanted to do a quick check, p times r times what is going to give me the first thing? It would be 25 times p times q. Because, and that would give me, let me go ahead and write the answer, that would give me 25 p squared q r. Because the 25 goes here, the p times p is going to give me p squared, q is going to give me that, and r is just going to stick along for the ride. And then a final check, pr times what is going to give me what's over here. It'll be 36 times r squared. So that will be 36 times p r cubed, because here I have r times r squared. I'm going to add the exponents. So that's the final answer there. So here we have p times r. So greatest common factor of monomials is really important. All you're doing is looking at two lists of variables and numbers and trying to figure out what the largest commonality is between the two of them. And it is important. We're going to be doing it a lot. So make sure you understand this topic. Work every single one of these yourself to make sure you understand what I'm saying. And then follow me on to the next lesson. We'll continue our journey in algebra.
Learn anything at mathandscience.com.